welcome back to yet another video for this week. We're going to be going over what we did on April 15th, and so we're going to be assuming the conservation of momentum and the conservation of energy for this question. And just a little reminder, or maybe if you don't know, just an opportunity for you to learn that momentum equals the mass times velocity. And so what we're given is m1 equals 1 kilogram, m2 is 2 kilograms, v1, the initial velocity, is 2 meters per second squared, or not squared, meters per second, and v2 equals, these are both initial, 1 meters per second, and we're supposed to find v1 final, v2 final. And then with the previous questions and problems where we did the conservation of momentum, so P initial equals P final, we were typically given most of these values except for this single one of them, and then just isolate, and it's just basically simple, very easy algebra, just applying the concept of conservation of momentum. But instead for this question, we're given both, or we're both not given the final velocity of the first object and the second object, mass 1 and mass 2. But let's set up the conservation of momentum. m1 v1 plus m2 v2 equals m1 v1 final plus m2 v2 final. Just standard conservation of momentum of the system, where these two is for the initial, these two are for the final momentum of the two objects, and we know these values, so we can plug in some of these values already, m1 being, or actually most of these values, and then m1, let's just do 1 v1f, make it less tilted, 2v2 final plus 2v2 final. And so in other situations where we would have probably had this variable and we could just isolate here, or vice versa, we now both don't have these values. And so just to simplify it down, 2 plus 2 is 4 equals v1f plus 2v2f. Now, for the sake of algebra, I'm going to take you guys through this, but you guys kind of have to trust me on this one, where let's set x equal v1f and y equals v2f. Just for more just to make it a little bit more simple. And I'll explain to you guys later why I'm doing this. And so the reason I guess I can kind of elaborate on it now, but the reason we're doing this right now is because we're going to have to use also the conservation of energy, and to mix and match some values or some variables to where we can finally isolate one of these variables. Because right now there's nothing that we can do. We have to plug in some value from somewhere into these values and then isolate one of the values, which is exactly what we're going to do with the conservation of energy. But the reason I made these x and y is because it's just a lot more clutter to put v1 and v2f for every time. Instead, for now, we're just going to put them as x and y. And so we know that energy is conserved. So kinetic energy is conserved because the cars that are moving, there's no potential energy. And so KE1 plus KE2 equals KE1 final plus E2 final. And we have most of these values anyway, so we could just plug them in, where it would just be 1/2 mv squared, but 1/2 1. We know v1 squared is 2 meters per second. 1/2 2 1 meters per second for v2 initially, then we get to our unknowns. V1 final plus 1/2, 2, just cancel out to 1, final squared. And so now that we have that, we could simplify that further, which is going to be 2 squared over 2, that's just going to be 2, and then 2 over 2 is going to be 1, so that's going to equal 3, so 3 equals 1/2 V1 plus V2F squared. And so with this, like we did earlier, let's just kind of swap it out just to make it a little bit simpler. X squared plus Y squared. Just like this. And so now that we have that, we can actually now finally plug in one of these values into another and use algebra essentially to isolate one of the variables. And so it would be a lot more complicated to isolate one of these and plug it into here. So let's isolate x on this end, where we would get x equals 4 minus 2y, and then plug that right into here. And so we should get 4 minus 2y squared over 2 plus y squared equals 3. And now that we have this, we can actually solve for y, because now that's the only unknown variable that we have. And so if you use the FOIL method and use out algebra, you should get 3y squared minus 8y plus 5 equals 0. And so that's what you should get. And then with that, you use the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. So that'll be 8 plus or minus b squared minus 4ac all over 2a. And so you should get 8 plus or minus 2 over 6. And so now once we have that, you can, so 8 minus 2 is going to be 6 over 6, which is 1, or it could also be 5/3, because that'll be 10 over 3 divided by 2 for both sides, it'll be 5 over 3. And then now we have these two values. Now, kind of thinking back to, okay, what is y equal again? Right here, V2F. So V2F can either equal 1 or it can either equal 5 over 3. My phone actually ended up losing storage, and so I kind of already solved out everything while the phone wasn't recording. But to kind of just give an explanation of why we chose, because I think I remember we left off on giving two possible options between having a velocity of 1 meter per second or 5/3 meter per second in a collision where cart 1 is pushing what ends up colliding with cart 2 as they're both going in this right direction. And so when we look at 1 and 5/3, you look at these original values, and for V2, for it to be hit in a direction in which it's already moving, the speed would not stay the same. Instead, it would actually increase, since 5/3 is obviously greater than 1 meter per second. And so using these values, I plugged in both values to also demonstrate on the other side for V1, where for V1, if it's going to hit an object, and that force is obviously going to be put in the opposite direction, since cart 1's force is in this direction, carts 2 equal an opposite reaction, so it's going to hit it back here. The velocity, instead of remaining 2 meters per second as the initial, it should decrease to 2/3 meter per second. And so using what you know about just physics, I suppose, you can make the assessment that, okay, this value or these values make more sense than these other ones.